All right, so we've been using the difference quotient formula to take an equation and move it through the difference quotient to get a second equation that tells us what the gradient is, the slope, at any point of the curve. And sometimes, it takes a while to go through, do the x plus h into both those, subtract it, divide out the h's. It takes a while. In fact, whenever there's x to the cubed, I haven't even given you any problems that are x to the cubed because it takes so long to go through and cube x plus h, okay? Unless you know the shortcuts. I don't bother teaching you them because what we're doing today, it's gonna make it so you don't even have to use this anymore. Anyway, if you have an equation like this, if you put it through the limit of the difference quotient, you would get this derivative, 15x squared minus 6x plus 2. Over here, you put 3x squared plus 2x minus 3 through the difference quotient, you get 6x plus 2. There's a pattern though. A couple of you have started to notice the pattern. Let's look at what the pattern is, because if we can see the pattern, maybe we can just totally skip using the difference quotient. If we can just skip it, well then there's going to be a lot less math involved. So let's look at what the pattern is, okay? Now we know this -3, it doesn't show up anywhere down here. Same thing with this +1, it doesn't show up anywhere down there, okay? That doesn't show up. The 2x just becomes a 2. So it lost an x. Here, this technically had an x. It was x to the 0 power. Well, now it's totally gone. Over here, there's technically an x to the 0 power, and it's totally gone, okay? So anything that doesn't have an x has disappeared. Anything that had one x, it just lost the x, okay? So that was x to the 1, x to the 1. Now it's technically x to the 0, because isn't anything to the 0 power just 1, or 2 times 1 is just 2, okay? Finally, we have this 6x. Where did the 6x come from? Where did the 6x come from? Well, what's 2 times 3? It's 6, okay. Now we noticed here there was 0, and there was 1. Well, 1 minus, when we get rid of the 1, when we got rid of the x's, became 0. So if we're getting 1 less, what's 1 less than 2? It'd be 1. There's kind of a little pattern happening here. So it looks like we take the exponent, we multiplied it by the 3, it gave us 6. There's 1 less x, so if it's 1 less than 2, that gives us just 1. So 6x. Here we get 1 less x, so 1 times 2 is 2. You have an x that is now gone, leaving you with this. Let's see if a similar pattern happens over here. We've got 3 times 5, which is 15. What's 1 less than the exponent? It's 2. Ooh, okay. So far it's following a similar pattern. Let's try this one. We've got 2 times -3 is -6. What's 1 less than 2? It's just 1. Ooh, okay, so x squared became just an x. Then finally, we had 1x here that's gone, so we're just left with the 2. If you notice, there's a pattern that's forming. Here is the pattern. So if we had 5x cubed, and we took the derivative, so we used the quotient, difference quotient, we would get 15x squared. This is what happened. You had a, which is the 5, a is just the constant, n is your exponent, okay? What you're doing is you're doing a times the old exponent, then the new exponent is 1 less than the old exponent. Okay, you're just subtracting 1 from the exponent every single time. Bloop. Okay, this n gets brought down. So 3 times 5 is 15. Then the new exponent is 1 less than the old exponent. So if it was 3, it's now 2. Kind of like it costs you an exponent to make this number bigger, to multiply it. All right, let's try 4 problems real quick. I'm going to do the first 2. I'm going to have you do the second 2. So if we're following the pattern that we've been doing, we could go through and use the quotient difference quotient on this and go through, do the x plus h divided by h minus f of x. Sounds horrible. Let's try this new pattern that we've been trying, okay? So what you do is you multiply the 3 by the exponent. That gives you 6. So f prime of x, f prime means the derivative, is 6. Then what is 1 less than 2? So we've got to subtract 1 from the 2. That's just going to be 1. Do I have to write x to the first power, or could I just write x? I can just write x. Okay? If you went through and used the difference quotient, that's what it would give you, 6x. Let's try this one. 20 times 5 is 100, so f prime of x is 100. X to the what power? 19. Okay. So again, if you went through and used the difference quotient on that, you would get 100x to the 19th power. Or you just use this shortcut, you can call it. It's called taking a derivative technically. Okay, we're taking the derivative here. All right, I want you to try these two real quick. Pause the video. Try these two on your own. On your mark, set, go. All right, you should have paused it. You should have your answer by now. Let's do these ones. This one, the answer is 0. What, Harper Smith? But there's the exponent. What did you tell us about the exponent? Is that an x? It is not. Okay, this is just a number basically. Pi squared is roughly 10. 10 times 3, so this is really just 30. So we've got f of x equals, this is roughly 30, okay? Now, if we remember back, you have to subtract 1 from the exponent. From the exponent of x. Since there's no x here, it's technically x to the 0. Well, you do 0 times 30. What's 0 times 30? It's 0, okay? So that gives us f prime of x equals 0 times, what's 1 less than 0? Negative 1. What's 0 times x to the negative 1? Well, it's just 0, okay? So that's how we're getting 0 for that answer. That's why it just kind of drops off. Because when you multiply it by 0, you're still stuck with 0. Let's try this one. We have a 1 up here. What's 4 times 1? That's 4, so f prime of x is 4 times x to the, what exponent is x going to have? 1 less than 1 is 0. What's anything to the 0th power? It's just 1. 4 times 1. So f prime of x is just 4. Okay? Tricky ones. Tricky, tricky, tricky. All right, let's try these 3 real quick. I'm going to do the first 2. I'm going to let you do the last one. We're going to take the derivative of each of these, okay? We're not going to say difference quotient rule anymore. We're just going to call it the derivative. We're taking the derivative. We are finding f prime of x. Okay, we are finding the first derivative. That's what the prime means. We're finding the first derivative of x. So we're going to follow the same pattern that we've been doing. What's 2 times 4? 8. What happens when you minus 1 from the 2? Oh, you're just left with 1. Perfect. Plus 1 times 3 is 3. What happens when you subtract 1 from 1? You get 0. And finally, this is to the 0th power. What's 0 times 2? Ooh, it's 0. 0x to the negative 1. Let's go through and simplify this a little bit. F prime of x equals 8x plus, that's just 1, so I can really just write 3, then 0, I don't have to write that. There we go. If I went through and used the quotient, difference of quotient rule, that's what it would end up giving me. I don't know about you, but I think this is a whole lot faster. Let's try this one, okay? 9 times 5, f prime of x is going to be 45, x to the 1 less than 9 is 8, minus 2 times 3 is 6, x. 1 less than 2 is just 1, and I don't have to write that, so I'm not going to write it. Here we've got 3x. 1 times 3 is just 3. Then do I have to write an x to the 0 power? Well, it's just 1, so I really don't have to. Here, the negative 2 is x to the 0 power. 0 times negative 2, it's gone. So if there's no x, kind of something just to remember, if there's no x next to the 2, it just disappears. Okay, because 0 times 2 is 0. And we don't have to write plus 0 on the end. There's your answer. Try this one. Pause it if you need to. Okay, you should have paused the video. I'm going to show you how to do it real quick. We've got f prime of x equals, let's figure this out. We've got 3 times 4 is 12x squared, remember it's 1 less, minus 1 times negative 3 is just negative 3. X to the 0 simplifies to 1. 3 times 1 is just 3, so I don't have to write the x down. The negative 5 times x to the 0 power, because x to the 0 power is 1. So there is an x to the 0 right here. 0 times negative 5 is just 0. Okay, so if it's just 0, do I have to write it here? No, we don't. That's our answer. This was so much faster than using the difference of quotient rule. So much faster. So, if you have questions, leave me drop a question in the chat below. Shoot me an email. I'm happy to help you. Or if you're currently in Zoom and need some help, let me know.